Okay, so now that we have a good handle on graphing sine and cosine functions, let's look at graphing some of the others and start with the easiest. Let's start by looking at the graph of the inverse of sine. So I've sketched a sine function in here and marked a couple of points. Notice at 2 pi, sine of 2 pi equals 0. Same thing is true here at pi. I'm not going to write the point just for neatness sake. And the same thing is true, the sine of 0 equals 0. So what happens to the inverse? If we know that the sine of x equals 0 at certain places, then we can make a leap to and a logical assumption to say that the cosecant of x, which is just equal to the inverse of sine x, putting sine x in the denominator, the cosecant at that point would be undefined. And of course, we show a function is undefined at its value of x, at any given value of x, by noting the fact that there is an asymptote at that value. So for the cosecant of x is undefined at the same angles that sine x equals 0. So the cosecant of x is undefined at 0, pi, and 2 pi, and multiples of pi, 2 pi, and 0 in both directions. The other thing that we can see pretty quickly is that whenever sine x equals 1, the cosecant of x, by the same logic above, equals 1 over 1. And let's say whenever sine x equals plus or minus 1, then the cosecant of x equals 1 over plus or minus 1, which means it equals either positive or negative 1 at those same values. So on the graph, that would look like these points here at pi over 2 and at 3 pi over 2. So these points. So if I put these two pieces of information together, it's not illogical for me to assume that given asymptotes on both sides and a point someplace in the middle, that the graph would go like this. And on the other location, like that. And in fact, that is exactly what the graph of cosecant x looks like. If I were to extend it on, I would get another one here, another one here, another one repeating, obviously, over some period. Same thing would happen on the other side. So I would certainly be able to identify all of the points at which the cosecant graph has an asymptote by first looking at all of the points where sine x equals 0, and all of the points where the cosecant graph intersects at exactly one point with the sine graph at whatever point the sine of x equals plus or minus 1. So that seemed to be a good method for understanding the cosecant graph. Let's use the same method to understand the graph of secant x. I'm going to start with cosine because we know that secant is the inverse of cosine. Let's label a couple of points. 2 pi 1, that would be 1 period of cosine, and 0, 1. I'm not going to label pi 1 because I'm going to end up doing the same thing. I don't want to make a mess of my work here. So I have cosine of x equals 0 sometimes, correct? It equals 0 here and here. And what are those values? Well, if this is pi, we know that cos x equals 0 at pi over 2 and at 3 pi over 2. If cosine x equals 0 at these two angles, we can assume that the secant of x, which is just 1 over the cos of x, would equal undefined. Right? So exactly the same thing we did only a moment ago on the sine and cosecant function. If cosine equals 0, then secant must be undefined, meaning we must have asymptotes at pi over 2 and 3 pi over 2, because secant x is undefined there. And using the same logic before, wherever cos x equals positive or negative 1, then the secant of x is going to equal positive or negative 1. Putting it together, I would have a graph that looks like this. Oops, I crossed my asymptote. That's not okay. Now, this isn't as useful to us, having this little partial curve on both sides. So often when we talk about a single period of the secant function, cosecant, it works out. One period of the cosecant function gives you one of these upward facing bowls, and then followed by a downward facing bowl, and each repeated period would just be a duplicate of that. This is a little bit more unwieldy, so we tend to look backward to negative pi over 2, where we would have another asymptote, and I can finish the upward facing bowl. And for some reason I'm not doing as nice a job of sketching these in as I was before. Let's see if I can get that done. There we go. And so often when we refer to the secant graph, we call the period, or a single initial period for the cosecant graph, as being between negative pi over 2 and 3 pi over 2, which gives us a whole period of complete upward facing, one upward facing, and one downward facing curve. Nothing wrong with doing it the other way. This just tends to be the period by which we identify if we need to talk about one period of the secant curve or the secant graph, we tend to identify the period we're talking about as negative pi over 2 to 3 pi over 2. All right, that's enough of that. Let's do an example. Let's graph y equals secant x minus pi, x plus pi over 2 minus 3. And so what this says is I'm going to take the secant curve and all of its asymptotes and everything. I'm going to move everything backward pi over 2 units and down 3 units, which means the asymptotes will all move backward pi over 2 units, and then each of these points at the upper bound and lower bound of the curve will also move backward and down. So it looks like all I have to do is track the mapping of the asymptotes and then track the higher and lower values, or I guess I should say the lower bound and the upper bound of the two curves. So let's do that. First, let's track and see what's going to happen to our asymptotes. If I can spell it, I can do it. So I have an asymptote at, I'm going to map, rather than mapping from 0 to 2 pi, I'm going to map from negative pi over 2 to 3 pi over 2. So I get two complete curves of the secant function. So the asymptotes are at negative pi over 2, which doesn't really matter at this point because I'm not going to continue on, but let's go ahead and track them. Negative pi over 2 is going to map to negative pi over 2 minus pi over 2 equals negative 2 pi over 2, which is negative pi. Or let's make my mappings go in this direction. This is just about making room on the page. Not that there's any right or wrong way to do that. All right, my next asymptote is at pi over 2. And they're going to map to, that one's going to map to pi over 2 minus pi over 2, 0. And then my third asymptote is at 3 pi over 2, 3 pi over 2, and it will map to 3 pi over 2 minus pi over 2, 2 pi over 2, which is just pi. So now I have my asymptotes, and what I need is to map 0, 1, the point 0, 1. And it's going to go, let's see, the x-ordinate is going to go backward pi over 2 units, so 0 minus pi over 2. And the y-ordinate is going to go down 3. 1 take away 3 is -2. And then the other point I care about for this graphing, for this translation, is at pi -1. Okay, and it's going to map to pi, take away pi over 2 is pi over 2. And -1, take away 3, -1 minus 3 is -4. And now I have everything I need to graph this graph in. I'm going to start with my, there you go, with my Cartesian plane. I'm going to put in my asymptotes, one at -pi, not really one I need, but I'm going to use it. Well, I guess I do, because this is going to move to the other asymptote. So -pi, 0, doesn't need a label, and pi. Okay, I have my asymptotes. Now let's plot our points. I have -pi over 2, so if this is pi, this would be -pi over 2, and -2. Okay, and then this other point is positive pi over 2, which is here, and -4. And now I can sketch my graph in, or my curves in. Not as pretty as we might like them, but that's what happens. Okay, so there we go. Almost. Almost. There we go, graphed. So there are some quick shortcuts to use, and I just used one when I showed you how to do this. When I graph this sort of a graph, a secant graph, I quickly sketch out the graph of the inverse. So if it's a secant, I'll quickly sketch out the cosine. I decided that I wanted to use this interval for the cosine. I decided where the asymptotes would be. And I decided where the high and the low points would be and what their coordinates would be. Translate all of those values using the point translation and the asymptote translation methods, and then plot them in and sketch your graph. So I think I can do one more example in the time allowed. Let's graph y equals 2. Oh no, let's do this. Y equals negative cosecant x plus pi minus plus 1. There we go. Okay, so I just made it up as I went. Y equals the negative cosecant x plus pi minus 1. Oh, let's make it -2 times the cosecant. Okay, I'm done. First, I want to sketch my sine, because cosecant is the inverse of sine. So I'm going to sketch in my sine curve really quick. I would naturally want to go this way, but this is a negative sine curve, so I know it looks like that. And it has a negative amplitude of 2, which means that this point is at -2, and this point is at +2. There's no period shift, so this is pi over 2. And then let's sketch in our asymptotes. We're going to have one at pi over, excuse me, that's not pi over 2. Why did you let me do that? That's at 2 pi. So we have an asymptote at 2 pi. We have an asymptote at pi, and we have an asymptote at 0 on the cosecant function, obviously not on the sine function, but let's see, 2 pi, pi, and 0. Then I have my two important points that I care about at pi over 2, -2, and at 3 pi over 2, and +2. So now let's figure out where those are going to be. My mappings for asymptotes, I don't have to write those mappings out. I think we can do it just when I graph the other graph, but I do want to map pi over 2, -2. So the x-ordinate is going to map backward pi units. So pi over 2, take away pi, is going to put me at negative pi over 2. And negative 2 up 1 is going to take me to negative 1. And then my other point I care about, 3 pi over 2 and positive 2 is going to map to, let's see, 3 pi over 2, take away pi is just pi over 2. And 2 plus 1 is 3. So now I can graph my graph. First put in my asymptotes. From 0, take away pi means I'm going to have an asymptote at x equals negative pi. Pi, take away pi, means I continue to have an asymptote at the y-axis. And 2 pi, take away pi, means that I'm going to have an asymptote at x equals 2 pi, take away pi at just 1 pi. Then my low point is now negative pi over 2 and negative 1. And my high point is at pi over 2 and 3. Oops. 3. And now I can sketch in my curve because I know exactly where it is. I'm going to have downward at this point and upward at this point. Done.